So recently I've got quite a few messages and links going to a new video that's been released on YouTube entitled The Wi-Fi Gun. Now the guys that created or actually run the channel, I am well aware of them. I have watched quite a few of their videos in the past, especially their microwave gun and EMP videos. Now a lot of those videos are for comedy purposes. You know, especially the microwave guns and the EMPs using magnetrons out of old microwaves, they just do not work. And I think when you view their channel, that's what you need to keep in mind. I find them very entertaining, but whether they actually work or not in real life is questionable. But this is a recent video they've released called the Wi-Fi Gun. This is an exact design of the one they built on their channel, claiming 5 kilometers, I believe. I've watched it a few times now. Now I'm not going to show you how to make this on my channel today. A couple of reasons. I'm not quite sure that I think we can improve it. Let's just say that. I think if I spend some time on this, some of the diameters are a little bit dubious, and I do think I can improve it. But I've built this exactly the same as theirs, and you can see the plans very briefly at the beginning of the video that they've used to construct this. I will tell you that they are very, very old plans. They have been around on the internet since Wi-Fi scanning and that sort of thing became a thing in itself. And this particular design, you used to see a lot of people putting these into cantennas, and they have got good results because it is a Yagi antenna at the end of the day, and a Yagi and a cantenna do make a really powerful long-range antenna. So to answer the question that I've got is whether this works or not and what do I think to it, well, I can safely say without testing it, forget about 5 kilometers. The king of distance when it comes to antennas is the cantenna, and then if you want to push it even further than that, you use a parabolic dish and a cantenna as the feed point, and that really is the king of distance. So a Yagi antenna, no matter what kind of design it is never going to compete with a cantenna, a well-constructed cantenna, when it comes to range. But I have built it, as you can see here. I've built it exactly the same as they have in their video. I've got a feed of coax coming out rather than you know, chopping down a dipole antenna to get the feed, but that's the only real difference here. So what I thought we'd do is we'll give it a scan. Now I'm not going to just start scanning and counting up all the different Wi-Fi access points. What I'm going to do, I'm going to choose one that I know is a set different distance from me here in my lab, and the access point that we're going to scan is 165 meters away from me, which is around 540 feet, and I've got no windows here in the lab, so it's straight off the bat, it's cutting through a brick wall, and I know exactly where the Wi-Fi access point that we're going to try and scan is. It's in a nearby school to me. In fact, you might, you know, be able to hear them playing outside at this moment in time, so it's not too far away, but it has got to cut through quite a few brick walls. So what I thought we'd do is I'm going to do a scan first with a cantenna, and then we can use you know, the signal that this picks up, and then scan the same access point with this, and we can compare the two, and we can see how powerful this really is. Now there is one thing about this design, and I've copied it exactly as it is in the video, as I said. There's one thing that you can do to this particular design to make it work better, and I'll show you what you can do to modify this to make it actually work better after we've done the first scan. Okay, so let's give this a scan then. The name of the access point we're looking for is office repeater, so let's see when it comes up. An office repeater is there at the top. It's currently at 78%, which means you could connect to this, you'd have good internet speed, and you know, a nice time browsing the internet. Anything below 50% really is poor quality and only really good enough for sending and receiving email. So you can see it's picked up quite a few access points there. The 100% ones, just ignore those because they are my access points here in the lab. But let's put this on a graph, and you can see there, nice and strong, nice red, and you know, generally a good connection. So let's put the Wi-Fi gun on then and see what kind of signal we get from that. So here we are then, we've now got the Wi-Fi gun in place, so let's give it a second scan. And remember, we're looking for the access point office repeater. So scanning away. So far I can't see the access point that we are looking for. One thing that you probably noticed from the screen already is we're getting far more access points in the like ambers and the greens there compared to the Cantenna, because the Cantenna, one of its downsides, it has a lot of range but it has a very narrow beam width, whereas a Yagi antenna doesn't have quite as much range, but it's much wider, so it can pick up more access points, but it just can't go the distance. And so far, oh, there you go, there's office repeater. It connected slightly and it got 54%, but now it's connecting, it's showing it connected again. So let's put that on the graph, and you can clearly see with the graph there, it's much lower than the Cantenna. The Cantenna was up in the 80s, this is down below the 50% mark, so not very good to certainly browse the internet with. Might get away with sending and receiving email, but the way it's dropping out there is it's not going to make you very happy. So not a very good signal there at all. It's dropping out quite a few times and then picking it back up, but it's really low, certainly below the 50% mark. Now, I did spot a problem with this antenna in the actual video, so let me set the camera up back on the bench and I'll show you what I think the problem is with this particular design. So now I'm going to show you the problem with this design as it is, and it's a problem with the construction of this. You quickly saw the plans pop up on the screen in the video, but plans, you know, quite often aren't enough. You need to know how it's all constructed and put together, and the biggest flaw with this is with the driven element. The driven element needs to be isolated from the rest of the antenna. It needs to be isolated from the boom, and it needs to be isolated from all these parasitic elements here, and it needs to be isolated from the back reflector. So the driven element is effectively shorted out to the rest of the antenna, and that is not a good thing. You don't have an antenna here. Now if you're using a Wi-Fi card with this for an extended period of time, you could end up damaging your Wi-Fi card. If you were to in fact hook a amplifier up to this as well as your Wi-Fi card, you would certainly blow that amplifier. It wouldn't last very long at all. So what can we do to fix this? So what we can do is use some heat shrink tubing, put it on the boom and the two nuts that are holding the main driven element in place, and isolate it from the rest of the boom of the Yagi. Now, as far as Yagi design is concerned, there's a lot of hot debate, especially with the ham radio guys, whether it's best to use a isolated boom or a metal boom and have all your parasitic elements and your reflector connected together as one unit, or use a completely isolated boom so they're all independent for each other. And that's a argument that's gone on for decades. I personally don't think there's any difference. Can make it a little bit easier to use a boom that's isolated from the rest, because then you don't have to worry about isolating the main driven element. But for me, I've built both, and I don't see much performance difference between either of them. As long as you isolate the main driven element, you will have a working Yagi. So now that we've modified the antenna, then let's give it another scan, and hopefully, fingers crossed, we've improved it. So we'll just let everything load up, and here it is already. I can see it's at 86%, so that's a definite improvement. So we've certainly pushed it up into the 80% mark there, so we'll definitely get a good internet connection if we were to connect to that particular access point. But as you can see, it's you know, this access point is nowhere near at 5 kilometers, and even if you had line of sight at 5 kilometers and low humidity, i.e. it's not raining or anything like that, you certainly would not be able to connect to an access point using this particular antenna. And now that it's no longer shorted out between the driven element and the rest of the Yagi antenna, the connection itself is a lot more stable. It's not dropping out, and it's holding itself at just above 80%, a really nice strong signal. So we'll definitely make a video in the future, and we will take this particular design of Yagi antenna and use it in conjunction with a waveguide cantenna, and hopefully then we can get something a little bit more powerful. But certainly when it's talking in the range of 5 kilometers, you really are pushing it. I mean, that's in the kind of range where you would need to use a parabolic reflector. So as you saw in the video then, with the little modification, you do get a much better performing antenna, and I will do a video where we take this kind of design and use it in conjunction with a cantenna, make them both together to get a particularly directional and much longer range antenna. But you are pushing your luck to try and get 5 kilometers, even line of sight and even in best conditions. Now, I didn't go over the measurements too much in this video because I will do that when I do a video on this, but just as a side note, the main driven element here, going off those measurements in the video, is 68 millimeters. Now that just seems a little bit too big to me. I mean, for this kind of element you're probably looking at about 62, 63 millimeters. I'll have to do a little bit of experimentation and some of my notes and read a couple of my books on this, but certainly 68 millimeters does seem a little bit big. But an antenna like this anyway is going to be extremely broadband, so it'd work on you know, quite a long wide spectrum, and the frequency for you know, 2.4 gigahertz Wi-Fi, but that does definitely seem a little bit big to me. So if you did find this video useful, then please give it a thumbs up. Any comments or questions, drop them below, and if you're going to make this antenna, please make sure you isolate the driven element, or you could end up breaking your equipment. And as for the original video, I did give the video a thumbs up. I haven't made a comment on the video, but as I said in the beginning, I do watch quite a few of their videos. They are entertaining, and you know, you need to take things like this with a pinch of salt.